On March 28, 1918, we took off in aircraft JA-28 to support our infantry. We were barely at 260 feet. Our plane took over 100 direct hits. My helmet was shot clean through, but the observer managed to bandage my wound right there in midair. I know for a fact that only a Junkers could have saved my life. No other aircraft of that era would have been capable of that. This vivid and revealing account of the Junkers J-1, the first mass-produced all-metal aircraft in history, was left by German Lieutenant Wagner, a World War I veteran. These specialized ground support aircraft came about largely as a response to British tactics. During the bloody Battle of the Somme, which began in the summer of 1916, the British began deploying what they called contact patrols. These were typically two-seat fighters or reconnaissance planes that didn't just observe German troop movements. They seized every opportunity to drop bombs or shoot up enemy soldiers and equipment. But this bold approach had a serious drawback. During low-altitude attacks, the planes became easy targets and losses from ground fire skyrocketed. The best, and probably the only reliable, way to solve this problem was to install heavy armor plating. While there had been earlier attempts to protect aircrews, it was the Germans who took this challenge most seriously. In late 1916, the German Military Aviation Command officially tasked engineers with developing an entirely new class of armored aircraft for direct ground troop support. These new aircraft were given the German designation Infanterieflugzeug, literally infantry aircraft. According to strict military requirements, the crew, engine, and fuel tanks had to be protected behind hardened nickel steel plates about 0.2 inches thick. That level of protection was enough to stop small arms fire. Because of the sheer weight of all that armor, the service ceiling was limited to just 4,900 feet. Initially, the armament was fairly modest, just a single rear-facing machine gun on a flexible mount. Each aircraft also had to carry a heavy aerial camera and a bulky radio set. One of the first companies to take on this challenge was the Junkers factory. The aircraft that rewrote the rules of aerial combat was the brainchild of Hugo Junkers, a German professor, engineer, and prolific inventor. Junkers held over 1,000 patents during his lifetime and made significant contributions to thermodynamics, precision instruments, engine design, and aircraft construction. He was also an effective organizer who brought together some of the best engineering minds of his time. Back in the late 1800s, he became fascinated with flight and quickly grasped a fundamental truth about aviation. To make an aircraft fly better, you need to reduce drag and cut the aircraft's weight, without sacrificing strength. To bring this idea to life, the designer patented a revolutionary concept: the thick profile wing. Junkers and his team spent years conducting countless studies, searching for the ideal wing profile and testing various materials. During development, they ran something like 4,000 individual tests and built over 400 scale models. Initially, Junkers tried building with thin iron sheets, but this material turned out to be far too heavy in practice. So the engineers turned their attention to duralumin. They began meticulously studying its properties, developing entirely new ways to shape and fasten this lightweight metal. Although aluminum was already widely used in building Zeppelin airships, Junkers ran into serious problems at nearly every step of the design process. Working with the new material was a constant struggle. Even so, he managed to build 3 working prototypes of all-metal monoplanes, single-wing aircraft. Later, at a meeting with military headquarters, a heated debate broke out over how the new armored aircraft should be designed. Conservative military officials insisted that the Junkers design absolutely had to be a classic biplane with 2 wings. Hugo Junkers flat out refused. He championed the modern monoplane design and argued that going back to a biplane would set the entire industry back. One of the project's lead engineers, Fritz Brandenburg, later recalled the difficult process like this: to truly protect the crew, engine, and fuel supply effectively, we had to create a special armored capsule inside the fuselage. And this steel bathtub weighed roughly 1,000 pounds. If the designers had opted to add defensive weapons, a 2-hour fuel supply, and full radio equipment for both crew members, the aircraft would have needed very long wings. But here was the problem. The wingspan would have been so huge that the plane wouldn't fit in any standard hangar or even a field tent. After long and exhausting debates, the engineers finally settled on a compromise. They chose what's known as a sesquiplane layout. While this design still included special struts, they were used exclusively to support the center section of the upper wing and distribute the landing gear loads. This clever approach is exactly what kept the wingspan manageable. Hugo Junkers took all of these considerations into account, but he understood one key advantage. Unlike the fragile planes made of canvas and plywood, his all-metal aircraft could handle snow and rain without any issues, which meant there was absolutely no need to shelter it in a hangar. The only thing that actually needed a tarp was the engine. Despite this, the project's uncertain future and serious disagreements with military leadership forced Junkers to abandon his monoplane concept. In the end, in early November 1916, the German Military Inspection Office IDFLIG officially ordered the construction of 3 prototypes. Other well-known aviation companies, including Albatross and AEG, received similar orders at the same time. 4 months passed, and in mid-January 1917, the new aircraft, fitted with a powerful 200-horsepower Benz engine, made its first short runs at Adlershof Airfield. Under the company's internal classification, this aircraft was designated the J-4. At the controls sat experienced pilot Arvid von Schmidt, who had been assigned to the Junkers team for testing. Assisting him was a non-commissioned officer named Vondler. During these first runs, the aircraft had no armor at all. Ordinary sheets of plywood stood in for the steel plates. 11 days later, the experimental aircraft was transported to the military testing grounds at Doberitz, where Arvid von Schmidt was to make a full maiden flight. The weather was far from ideal. The ground was covered with a layer of snow about 8 inches deep. Still, the aircraft picked up speed into the wind, needing a run of over 650 feet to get airborne. In that historic flight, it reached an altitude of nearly 820 feet and hit a speed of about 90 miles per hour. But even though the aircraft was significantly lighter without the heavy steel plates, not everything went perfectly. As it turned out, the tail section was far too heavy. The pilot had to pull the control column back with all his strength just to get this beast off the ground. Watching these first flights closely was Lieutenant Madelung. The military had specifically dispatched him to the factory to personally oversee the development process and verify whether the new aircraft met the strict Army requirements. Even so, the early flight results looked very promising. So the military wasted no time. They ordered 100 of these aircraft right away. The official contract for the first batch of 100 armored biplanes, which the Army designated the Junkers J-1, was signed on February 19, 1917. But getting the new aircraft into mass production turned out to be far from simple. First, Hugo Junkers' factories were stretched way too thin. The thing was, aside from building aircraft, the company also had to fulfill other government orders, like producing field kitchens and water heaters for the Army. The second major obstacle was a massive delay in steel plate deliveries. Armor plate from the Dillingen Steel Works didn't start showing up until late May 1917. Meanwhile, mandatory government trials, which the aircraft had to pass before being officially accepted into service, had already begun in early March. These critically important tests were once again held at Adlershof Airfield. Engineers and military officials meticulously checked the structural integrity, engine reliability, and tried to install all the required equipment. According to strict Army regulations, the test aircraft was supposed to be an exact copy of future production aircraft. But in reality, things turned out differently. The Junkers company, lacking proper experience with military trials, submitted an aircraft that could barely be called a pre-production model. It was missing its standard armament, had no radio, and no aerial cameras. To be fair, the actual armor was fitted shortly after testing began. The aircraft was also missing several required wing struts, and the upper wing sat so close to the observer's cockpit that it was nearly impossible to use the machine gun properly. The testing committee hoped that Junkers would take the criticism to heart, so they decided to continue the trials. The main condition was that all the necessary modifications would be made right during the testing process. Keep in mind, back then there were no established standards for stress testing all-metal wings, so a lot of this was being done for the very first time. Despite all the technical hurdles, the designers managed to solve most of the problems. For instance, they came up with a surprisingly elegant fix for the heavy tail. The heavy metal skin on the tail and vertical stabilizer was replaced with light fabric. They cut an opening in the upper wing and reinforced several key structural elements. The engineers also redesigned the fin and rudder to improve handling. All of this extensive work was carried out at the military airfield in the city of Hull. It had vast hangars and a very long runway, essential for getting the heavy J-4 attack aircraft up to takeoff speed. Meanwhile, another prototype was undergoing rigorous testing at the Dobert base, while the main factory in Dessau was gearing up for mass production. The first production J-1 was sent to the front in Flanders on August 1, 1917, where it joined Fliegerabteilung 19, a German aviation section. Hugo Junkers soon received an enthusiastic telegram from pilot Arvid von Schmidt, who had been conducting combat trials with the new aircraft. The pilot reported that during a flight over the city of Ypres at an extremely low altitude, about 160 feet, his aircraft took 11 direct hits but suffered no serious damage. Arvid von Schmidt particularly praised the reliable engine armor and excellent speed. In these areas, the J-1 significantly outperformed rival aircraft in its class, such as the AEG and Albatross types. Thanks to its all-metal construction, it also handled bad weather far better. In late September, mechanics conducted a thorough inspection of this aircraft, and the results were impressive. It turned out the plane had survived 85 hits from bullets and anti-aircraft shrapnel, yet was still in excellent condition. By early October 1917, military command had gathered enough data to form a definitive opinion about the new aircraft. Frontline pilots all agreed that the J-1 was stable during maneuvers, held steady even in strong gusts, and was surprisingly fast. The construction proved so robust that in the event of a sudden engine failure, and at the front, that happened more often than you'd think, the armored fuselage gave the crew an excellent chance of surviving a hard crash landing. But there was a flip side. Because of its considerable weight, the Junkers needed a long runway, which made it really hard to operate from small, improvised frontline airfields. Engineers even tried fitting the landing gear with special brake wheels to shorten the landing roll, but it barely helped. Still, the heavy J-1 aircraft were actively deployed to specialized infantry support units, which were attached to division or even corps headquarters. In combat, this aircraft proved highly effective at performing low-altitude reconnaissance missions, even under heavy enemy fire. The crew could drop light bombs and grenades on enemy trenches in a single pass. These armored planes were also frequently used to maintain communications and for the risky business of delivering ammunition and supplies to soldiers right at the front line. And even though the J-1 had a famously poor power-to-weight ratio, poor maneuverability, and limited visibility from the cockpit, it quickly became a real favorite among the troops. Frontline pilots deeply respected this plane because that thick armored capsule gave the crew near-total protection from ground fire. The biggest threat to these lumbering aircraft remained enemy fighters. The observer's single machine gun couldn't provide adequate coverage, so command strongly recommended these armored planes always fly with a dedicated fighter escort, positioned significantly higher to provide cover from above. Junkers aircraft regularly returned to base after heavy combat, riddled with bullet holes, but fatal losses were extremely rare. One frequently cited account describes a J-1 returning to its airfield with reportedly 480 bullet holes in its wings and fuselage. Amazed by this toughness, pilots gave the aircraft several colorful nicknames. German crews called it Der fliegende Tank, the flying tank. Others went with the Tin Donkey, or my personal favorite, the flying furniture van. The Allied forces had almost no intelligence about the J-1 until early 1918. The first real intel only came in when several abandoned aircraft were captured during a major German retreat. At the same time, some French military reports claim that at least one of these armored planes was forced to land after sustaining critical damage from concentrated anti-aircraft fire. No real confirmation of this was ever found, though. As for the aircraft's appearance, these planes had a specialized camouflage scheme that remained virtually unchanged right through the end of the war. The upper surfaces were covered in irregular patches of green and purple to help the aircraft blend in with the terrain, while the underside was painted light blue to disguise it against the sky. The landing gear, wheels, and the armored fuselage section were painted green, sometimes with a few purple splotches added in. A similar camouflage scheme was frequently used on many other aircraft assigned to direct infantry support. Toward the end of combat operations, the tail section began to be covered with a special fabric that was factory printed with a 4 to 5 color camouflage pattern. So that friendly troops on the ground could easily identify the aircraft, bright signal streamers were occasionally attached to the lower wing, and large recognition markings were painted on the underside of the upper wing. In the summer of 1917, the German aviation inspectorate known as IDFLIG began showing even greater interest in the Junkers J-1 attack aircraft. But due to a severe shortage of production space, output of these aircraft remained extremely low. And this despite the fact that back in January, Hugo Junkers had planned to assemble 30 to 50 aircraft per month. To somehow resolve this crisis, IDFLIG leadership proposed combining efforts and creating a joint venture between two prominent aviation companies, Junkers and Fokker. Both designers reluctantly went along with this forced partnership. But on October 20th, 1917, they nonetheless established the joint corporation Junkers Fokker Work AG. From that point on, all aircraft coming off this new company's production line carried new JFA markings, short for Junkers Fokker, on the landing gear wheels, replacing the earlier Junkers branding. Shortly after this merger, on November 6th, a major contract was signed for 100 additional combat aircraft. But Anthony Fokker quickly realized that production at the Junkers factories was poorly organized, and the workers didn't have the hands-on experience needed to build aircraft. And even though Fokker received very generous funding and skilled personnel for this project, the young Dutch designer decided to wash his hands of the whole arrangement. He officially claimed he was too busy with other projects. While Anthony Fokker was preoccupied with his own affairs, Hugo Junkers wasn't wasting any time. He was taking over Fokker's production facilities, step by step. In January and February of 1918, the factory was averaging 17 aircraft per month. At that point, over 500 workers were employed in the workshops. But thanks to Junkers' persistence, by November, the workforce had expanded to more than 1,000. That determination paid off. In October 1918, the company set an all-time production record: 31 aircraft assembled in a single month. There were serious setbacks along the way, though. For instance, large-scale production nearly fell apart due to severe flooding in January of that year. The disaster forced a complete shutdown of armor production at the Dillingen plant, which meant the Army didn't receive a single finished aircraft in March. To salvage the situation, management desperately searched for new armor suppliers, pinning their hopes on other metallurgical companies such as Ostschlesische Eisenindustrie and Rochling. Another persistent headache was the lack of a proper, spacious airfield in Dessau. Because of this, finished Junkers J-1 attack aircraft had to be transported to Doberitz, where their official inspection and acceptance took place. In late 1917, the final assembly and test flight processes had to be relocated to a new airfield at Wörsen, near Leipzig. And by mid-February 1918, the Eidflieg Inspectorate issued an order requiring all new aircraft to be delivered for military acceptance directly to an Army aviation depot, Army Flugpark 17. But the enormous distance between the factory and this depot made handling that kind of logistics nearly impossible. Meanwhile, the Junkers Company finally secured a plot of land for building a large company airfield right next to the factory buildings. Thanks to this, by May 1st, 1918, every stage, from assembly to testing and delivery, was happening in one place. But for some baffling reason, in August the acceptance process was moved back to the distant Army Flugpark 17. All of this red tape seriously slowed down deliveries to the front. Yet demand for the Junkers J-1 was growing rapidly, and orders kept piling up. On June 20th, a request came in for 40 more aircraft, and right on its heels, on July 12th, another contract was signed for 10 more. During this same period, the Linke-Hofmann Company in Breslau received a large-scale order to build 100 Junkers J-1 aircraft under official license. But this production never got off the ground, and the deal was most likely canceled. The last major contract was signed in October, calling for 80 more combat aircraft. But in November, the armistice was signed, ending the war. After that, no new orders came in. Still, Command issued a directive allowing factories to continue production, though now under strict Allied oversight. In the end, by January 1919, out of a total order for 283 aircraft, 227 Junkers J-1 attack planes had been built, with 43 of them completed after the war had ended. Earlier, on October 2, 1918, Hugo Junkers and his team had gathered to discuss the future of their famous J-1 aircraft. Junkers continued to push for a parasol-type design, a wing mounted above the fuselage. He considered this design far more aerodynamic. Plus, this configuration gave the crew excellent visibility both forward and downward, which was critical in combat. The following day, Hugo Junkers was unable to attend the discussion. That's when word started going around among the engineering staff. The German Aviation Inspectorate, Eidflieg, was seriously considering shutting down J-1 production altogether. The main reason cited was that the aircraft was simply too complicated and time-consuming to build. To save the situation, the team scrambled to find ways to make their infantry plane cheaper and faster to produce. By that point, the company already had an assembly line running like clockwork. What's more, if production were suddenly shut down, some 300 skilled workers would suddenly be out of a job. So the design team decided to focus on cutting weight and stripping out unnecessary equipment. For starters, the armor weight was cut by 220 pounds. The plate thickness was now roughly 1/8 of an inch on the sides and about 1/4 inch on the rear wall. The engineers also reworked the wing structure, making the wingspan larger, and replaced the old fabric covering on the rear fuselage with durable duralumin. To shed even more weight, they removed the camera and the heavy radio set. This made perfect sense, since during ultra-low altitude flights, that equipment was almost never used anyway. All the design work was only completed by December 1918, meaning after the armistice had been signed and the war was effectively over. One of the company's production aircraft was selected to incorporate these modifications. Not much is known about this particular airframe, but it was likely built to the drawings approved at the October meeting. Testing of the upgraded aircraft didn't begin until mid-January 1919. The few surviving photos of this plane come from exactly this time. Some aviation historians speculate that if this updated model had gone into full production, it might have received a new designation, J2. But no official documents from either the Junkers company or the military inspectors confirm this. Looking at the construction of the base J1, its forward section formed a formidable armored compartment. It consisted of a heavy armored box stretching 11.5 feet long. Inside this protective capsule sat the engine, fuel tank, and the crew themselves. To prevent the structure from warping under stress, it was additionally reinforced with internal duralumin frames. The thickness of this steel armor ranged from about 1/6 to just under 1/4 of an inch, making the aircraft extremely tough when taking enemy fire. The heart of the aircraft was its powerful engine. Typically, the reliable Benz BZ4 was used, producing 200 horsepower. Occasionally, however, the more powerful 260 horsepower Mercedes D4A was installed instead. This heavy engine was mounted on sturdy ashwood beams and further supported by an intricate framework of duralumin tubes and steel plates. To protect the most vulnerable component, the engine cylinders, they were shielded from the front and sides by thick steel panels. The fuel tank held about 26 gallons, was soldered from solid brass sheets, and doubled as the pilot's seat. A risky but clever solution, and one that saved a lot of space. The rear section of the aircraft, meanwhile, was completely different from the armored nose. It was a lightweight but strong skeletal framework, entirely assembled from duralumin tubes connected by diagonal cross braces. The wing structure was classic for the period. Each wing consisted of a center section and outer panels. The upper wing was attached to the fuselage using massive steel tubes that crisscrossed each other for added strength. The standard wheeled landing gear was mounted to the lower center wing section. This entire assembly was rigidly connected by special angled struts, forming one solid, rigid structure. The upper wing was enormous. Its span reached 52 feet 6 inches, with a total area of nearly 388 square feet. The lower wing was noticeably smaller, spanning just over 35.6 feet. On top of that, the wings had a slight upward angle of 5 degrees, which helped keep the aircraft stable. The wing itself was very thick at the center, but tapered sharply toward the tips. To withstand the enormous loads during flight, the upper wing contained no fewer than 10 load-bearing spars made of strong duralumin tubes. These were interlaced with smaller tubes, creating an intricate web much like the fuselage structure. The lower wing was built on exactly the same principle, but had only 6 such spars. The aircraft's trademark was its corrugated duralumin skin. Corrugated metal sheets just 15 thousandths of an inch thick, barely 4/10 of a millimeter, covered the wings and fuselage, securely riveted to the framework. The horizontal stabilizer was no small piece either, 49 square feet in area. It too was built from tubular spars and covered with the signature corrugated metal. The stabilizer's shape closely mirrored the main wing, with a maximum thickness of 7.4 inches. Originally, the rudder and fin were covered with standard aviation fabric. Over time, though, as the aircraft was refined, the engineers moved away from fabric, and on later versions, the entire tail assembly became fully all metal, made from the same reliable duralumin. The aircraft was controlled using a classic cable system, a reliable and straightforward system that pilots already knew well, linking the control surfaces and ailerons. The observer, seated in the rear, had a parabellum machine gun on a turret that could rotate freely. On combat missions, observer gunners often wore standard infantry helmets to provide at least some head protection. Like other aircraft in the J class, the Junkers J1 had no synchronized machine guns for firing through the propeller. This aircraft was too slow and too unwieldy for any kind of dogfighting. Attacking ground targets in a steep dive was also out of the question. The low operating altitude and poor maneuverability wouldn't allow it. The ammunition consisted of drum magazines holding a total of 1,000 rounds. They were positioned for easy access, to the right and left of the gunner, as well as directly beneath his seat, so that reloading took as little time as possible. Beyond the guns, the crew could carry light bombs weighing up to 110 pounds total. The crew attached them to racks along the fuselage or stacked them in the cockpit. The engineers also experimented boldly with the armament. For example, on one aircraft they tried installing a pair of Spandau machine guns, the LMG 0815 model. These were mounted directly in the fuselage floor, with their barrels angled forward and downward at 45 degrees. The idea was to make strafing ground targets far more effective. In January 1918, the designers went even further. They installed a 20mm Becker autocannon. They secured it on a bracket, similar to the setup used on Albatross J-1 attack aircraft. But just like the additional machine guns, this powerful cannon on the Junkers never made it past the experimental stage. Today, only one fully intact example of this remarkable aircraft survives. You can see it in Canada. It's on display at the Canada Aviation and Space Museum at the historic Rockcliffe Airfield in Ottawa, Ontario. This aircraft crossed the Atlantic back in 1919 as a war trophy, after which it was officially transferred to the museum collection. It has since been restored, but due to limited funding, the restorers had to take shortcuts with historical accuracy, so the repair techniques used bear almost no resemblance to the original manufacturing methods. Right up until the start of World War II, a J-1 airframe was on display in the main exhibition hall of the Junkers Company in Dessau, Germany. It was displayed in a partially assembled state, showing the final stages of construction, which allowed visitors to examine the aircraft's all-metal skin and rear fuselage structure in detail. On March 7, 1945, during a large-scale Allied bombing raid, this museum piece was lost forever, and its fate remains unknown to this day. Still, a small piece of history did survive in Europe. In Milan, Italy, at the National Museum of Science and Technology, the original pilot's armored capsule is carefully preserved, along with the duralumin structural framework of the rear fuselage section.